surface area of the cylinder. Okay, so the first thing we need to do, just like we always do, is write the problem down. There's the top of the cylinder. Okay, it goes down, and here's the bottom of the cylinder. Okay, now this cylinder has some radius r, okay, and this cylinder is some height h. So that's those are kind of the two parameters that describe the cylinder. You've got the circle part of it, and you know the radius of that circle, and you also know how high or how tall the cylinder is. Okay, now what we want to do when we calculate the surface area of this thing is what we really want to do is we're looking at the total surface area. That means we're looking at the area of the top face and also the bottom face, this area here and the bottom part that you really can't see in this drawing, okay? And also you want to notice and look at the area of the part going all the way around the actual curved part of the figure as well, okay? So we have the area of the top, the area of the bottom, and the area of this entire region around like this that we need to worry about. So in order to understand how we're going to calculate the surface area, let's look at all those pieces. Okay, so what I want to do is I want to just pretend, have some scissors, and I want to cut the cylinder up, and I want to spread it out, and I want to look at all the pieces, okay? And we'll figure out how to calculate the area when we do that. So let's go ahead and do that. If I do that, then the top of the surface of the cylinder is going to be represented by a circle, which is what we have here, of radius r. And let me go ahead and finish spreading it all out here, and then I'll explain what we have. The middle part, okay, is going to look like a cylinder. And let me just draw it, and I'll explain what I'm looking at. And the bottom part is going to look like another circle, okay? So what have I done here, okay? This circle, okay, is if I cut this thing with some scissors and I kind of spread it out, then the surface, this represents the top piece, just this top piece if I were to fold it flat. The bottom represents the bottom piece if I were to fold it flat. And if I take my scissors and I cut the cylinder and I spread it open, this cylindrical piece in the center here is just going to be a rectangle. If you just cut, you know, a paper towel tube and spread it flat, you can see that this is going to be a cylinder. Okay, so all I need to do to find the surface area of the whole thing is to find the surface area of the top, okay, the surface area of the bottom, okay, and surface area of tube, the surface area of the tube part, okay. So let's go ahead and do that right now. Okay, so the surface area of the top, and I'm going to go ahead and put in parentheses or the bottom because they actually look exactly the same, okay, is going to equal, and can you guess what this is? We talked about this in the last section. This is a circle with radius r, okay, so it's just simply going to be pi times r squared. That's the surface area of this piece or this piece, okay, just by using the formula for that. Now the surface area of the tube is, and I'm just going to go ahead and write it down and explain to you why it's true. It's 2 pi r times h. Now before we go any further, I need to explain what happened here and how we knew this was the answer. Okay, what is 2 pi r? Okay, what is 2 pi r? I think you might remember that from the last section. 2 pi r is the circumference of the circle. Okay, so think of it this way. It's the circumference all the way around the tube. It has nothing to do, 2 pi r has nothing to do with the area of anything. It's simply the circumference around that tube. But if you think about it, this distance right here, okay, this distance right here of the tube is 2 pi r, okay? And the reason it's 2 pi r, actually, I don't want to confuse you. In reality, it's this distance right here when we're looking at the drawing like this. It's 2 pi r, Because if you think about it, if I cut this tube and spread it out, okay, then if I actually cut it and spread it out, then the length in this direction is just going to be equal to the circumference all the way around, right? So if I cut it, if you imagine if I cut it, that means I put my scissors and I cut it and I make a big cut right here, okay? And then I spread it out. Well, you can see that as I spread it out, the actual length in this direction is equal to the circumference all the way around this circle, okay? So that's why the distance in this direction is just simply 2 pi r, given by the radius here, because we're cutting this circle and we're spreading it flat, and that's why you have a radius here. Okay, and that's just equal to the distance. Okay, now the distance this direction is just simply the height, and in order to get the area of any rectangle, you multiply one dimension times the other dimension. So 2 pi r times the height times the height. Okay, that's how you get the surface area of this tube. It's the distance all the way around, which gives you the length, and the height times the height gives you the surface area. Okay, so now that we know, how to do that, the total surface area is going to be equal to this area plus this area plus this area. So what we're going to have is pi r squared for the top plus pi r squared for bottom plus 2 pi r h for the tube. Okay, so the area of a cylinder in the end is going to be pi r squared plus pi r squared is 2 pi r squared plus 2 pi r h. So there you go. We just derived it. Now the actual result that you need to remember is the area of a cylinder is 2 pi r squared plus 2 pi r h. Now, you may not think you'll be able to do this right now, but I guarantee you after using this formula a few times, you'll be able to just remember the result. Even if you don't actually memorize it, you just need to start thinking to yourself, area of a cylinder. How do I need to go ahead and remember that? Well, I need to know the area of the tube and the area of the top and bottom. Area of the top and bottom is pi r squared plus pi r squared gives me 2 pi r squared. Area of the cylinder is going to be 2 pi r because it's the circumference all the way around times that height to give me the area of this rectangle, quote unquote, if I were to spread it out. That's how I get that term. Okay, so let's go ahead and use this in a problem. So the problem is, here's a cylinder, okay, and the radius is 4 centimeters. And the height is 5 centimeters, okay? And you want to find the area. So the area of the cylinder, you just need to start remembering, is 2 pi r squared plus 2 pi r h. Okay, so it's 2 pi, and r is the radius, which is 4 squared, plus 2 pi, r is the radius, times h, which is 5. Okay? So we're just plugging in the radius into here, and the height over here. When we multiply this out, we're going to get 2 pi times 16, 4 times 4 is 16, plus 2 times 4 is 8, 8 times 5 is 40 pi. Okay, so we're just multiplying the numbers, and we always just keep our pi, there, okay? Now, when you go off in your calculator and you put 3.14 in here for pi, and you put 3.14 in here, and you start doing this multiplication, you'll see that you get 100.48 plus 125.6, and when you add these up, you'll see 100.48 plus 125.6, you'll get 226.08. And we're dealing with centimeters, and we're dealing with area, so it's centimeters squared. Okay? So that's how you do it. All you have to do is use the formula that you have, plug in the radius and plug in the height, and work through it. And now you know how to calculate the surface area of the cylinder. And you know, this could be useful for instance, if you had some, I don't know, let's say you were painting some water tower or something, and you're going to need to know how much paint to buy. And so you could use this to calculate the surface area of the object, and you would know how much paint to go buy, because typically on the back of a can of paint, it expresses how many square feet or how many square meters that can of paint will actually cover. Okay. Let's go ahead and go to the next problem, which is going to look like this. Cylinder like this. Okay. In this case, I'm not given the radius, I'm given the diameter, which is 2 meters. Okay. And I'm told it's 12 meters long. So how do I find the surface area? The area is 2 pi r squared plus 2 pi r h. Okay? But notice I've got radius and radius, but I don't actually have radius in the problem. So I need to calculate that. So the radius is equal to, you have to calculate that first, the diameter divided by 2. That's just a definition. You take the diameter, you divide it by 2, you get the radius. The diameter is 2, so I'll plug it in, divided by 2 here. And so when you crank through this, you'll find that the radius is going to be 2 divided by 2 is 1 meter. And the radius is what you actually use in here, not the diameter. Okay? So the area is equal to 2 pi times 1 squared, because the radius we just found is 1, plus 2 pi, again, 1 is the radius, and the height of the cylinder, because it's on its side, is just 12. Okay? Okay, so we start multiplying through here. We have 2 pi plus, because 1 squared is just 1, and 2 pi times 1 times 12 is just going to be 24 pi. Okay? And now you can start plugging in for pi. And 2 times 3.14 is going to be 6.28, just plugging in 3.14 in there, plus 24 times pi is 75.36. And so the area, when you add these two numbers together, is just going to be 81.64, and it's square meters because we're dealing with meters, and the unit of area has always got to have a square, because we're talking about units of square meters. Now we're going to go ahead and tackle the concept of the volume of a cylinder, and let's go ahead and do that right now. Okay, so for the volume of a cylinder, let's go ahead and calculate the volume of that. Okay, a cylinder obviously looks like this, same as before. Okay, it has some height, just like before. Okay, now what we're going to do, and it has a top and a bottom, just like before. Okay, the thing you need to remember is that the volume of a cylinder, in general, just like the volume of any prism that we talked about a few sections ago, is just simply the area of the base times the height. Okay, the area of the base times the height. And you can think of that quite simply as any three-dimensional object like this that goes up and down. You look at the area of the bottom, that's giving you the square meters. Multiply by the meters in this direction, you kind of stretch that area up and kind of add that area up all the way through the object, and you get the volume. So in general, it's always the area of the base times the height. Okay, but you already know what the area of this is, because this has some radius r. Okay, you already know what the area of that is, which is pi r squared. That's the area of the base times the height. So the volume of the cylinder is something you'll just have to remember, pi r squared h. But like I said, even if you don't remember it or memorize it, it's okay, because you should just think about, well, how am I getting the volume here? The area of the base times the height. I know what the area of the base is. Put the height in, and that's the volume of the cylinder. So let's go ahead and work a problem. Okay, have a cylinder on its side. Okay, and I'm given the radius, which is 3 meters, and this is 12 meters long. So the volume is simply pi r squared h, just like before, just like what we talked about right here. Okay, and so I'm going to go ahead and plug in pi. R is 3 squared, and the height, or the length in this case of the cylinder, is 12. So it's pi r squared h. Okay, so the volume is equal to pi, 3 times 3 is 9, times 12. 9 times 12 times pi. if you were to put that all in your calculator, is going to equal to 339.12 cubic meters. And it's cubic meters because we're dealing with meters here, and we're dealing with volume. So we've got to have a cube there. So you see, the math isn't that hard. You just have to know what number to put into each variable. Okay. Let's go ahead and do another one here. Let's say we've got volume like this, cylinder oriented like this, and now I'm given the diameter, which is 18 centimeters, and the height is given as 4 centimeters. Okay. Now how would I calculate the volume of this cylinder? Well, the volume is going to equal pi r squared h, okay, which is equal to pi, the radius, actually I'm not even given the radius, I'm given the diameter. Okay, I'm given the diameter before, so now you hit a roadblock right away, you need the radius. How do I find the radius? Well, the radius is equal to the diameter divided by 2, by definition is the radius. So it's 18 over 2, which is 9. 18 divided by 2 is 9, so let's use this number. 9, don't forget you have to square it, because it's pi r squared h, and the height in this case is 4. So the volume is equal to pi times 9 times 9 is 81, and got to have the times 4 here. Okay, so when you go in your calculator and you have pi times 81 times 4, what you're going to get is a big number, 1017.36, and you have to have cubic centimeters because we're dealing with centimeters and we're dealing with volume, so you have to have cubic. So here the only snag was that you weren't actually given the radius, you were given the diameter, and you had to calculate the radius. Okay, now we're going to talk about the volume of a cone. And this isn't one of those things that's easy to actually derive. It's something that you mainly have to memorize. There are a few of those things in life. So go ahead and memorize the volume of a cone. So here, the volume of a cone. Okay, the volume of a cone. If you have a cone that's kind of like this, okay, this cone is going to have some height to it, right? And this cone is going to have some radius of the circle part of the base, okay? The volume of a cone, you just have to memorize, is equal to 1/3 pi r squared h. 1/3 pi r squared h. Now you can see there's a pi r squared here, so you're taking into account the area of the base, but this isn't really a prism. It's not it kind of pulled up from the base. It's got a different shape as you go up. So you have to have you have the h here, the pi r squared h, okay? But this factor of 1/3, and notice the pi r squared h, by the way, would be the area. It would be the volume of this thing if it were a cylinder. Okay, because we just talked about that. If it were a cylinder, it would be the area of the base pi r squared times the height if the thing had come up like this. So this 1/3 is really just a factor that you put in there to chop it down and show you that it's not really a cylinder, it's a cone, and that factor is 1/3. So you just kind of have to remember that and use this formula there. So let's go ahead and work an example showing this, okay? And we will show it like this. You have a cylinder here. Okay, you have a cylinder there, and the height is given to you by 6 meters. Okay, that's what that means. And this radius here is given to you as 4 meters. This is a radius, 4 meters. So we want to calculate the volume. The volume is equal to 1/3 pi r squared h, same as what we had right here. Okay. And so the volume is going to equal 1/3 pi. R is given to us. The radius of the base is 4 squared, and the height is 6. Okay. So it's 1/3 pi. 4 times 4 is 16, so I just put it there times 6. Okay. And now we're going to multiply all this stuff out. 6 divided by 3, because I can multiply all this in my calculator right now if I want to, but I want to simplify it a little bit. 1/3 times 6 is basically going to be 2. So 2 pi times 16. 2 pi times 16. Okay, because basically you have 6 over 3 here. 1/3 times the 6 is 6 over 3, and that gives you the 2 there. Okay, and I just kept everything else exactly the same. And that just looks a little bit simpler to me. So you can take this, put this in your calculator, 2 times 3.14 times 16, and you will get 100.48. And we're dealing with volume, and we're dealing with meters, so it's got to be cubic meters. Okay? Next problem for a cylinder. I'm sorry, next problem for a cone. You have an upside down cone like this. Okay? The radius is 5, okay, and the height is given as 11, and these are inches, and so the volume is the same no matter what the units are. It's 1/3 pi r squared h, okay, so it's 1/3 pi, radius is equal to 5, so I'll put 5 squared, and the height is equal to 11, okay. So the volume is equal to 1/3 pi. 5 squared, 5 times 5 is 25 times 11. Okay? And I'm just going to go ahead and rip through my calculator here. 1/3 times pi times 25 times 11. You just go ahead and put it all in there. Or you can do that by hand. And you'll get 287.83. And here we're dealing with inches. So it's going to be inches cubed because it's volume. And now we're going to tackle the surface area of a sphere, okay, of a sphere. So think of a globe, or think of a beach ball or something. That's what a sphere is, okay? So we have the surface area of a sphere. Okay, now I'm just going to go ahead and give you the formula here, and that's sort of the easiest way to proceed. Here's a sphere, okay? Okay, and if you look at this, this is a band all the way around the center of the sphere, or the kind of cutting through the diameter there. And you'll always have some radius, r, okay? And so that's going to be important. So the surface area of a sphere is equal to 4 pi r squared. You're just going to have to remember that. Notice that you have pi r squared, which has something to do with the fact that this is a circular type of figure. Okay, but you have this, and that's a surface area, but this factor of 4 is kind of a multiplier that allows that to be multiplied and just kind of cover the whole volume. And in truth, you really can't derive the surface area of a sphere here. You really need to use calculus to figure that out. In fact, when you guys move on to calculus, you'll be using that to derive the volume and the surface area of all this stuff. But for this case, you don't really need to think too much about where it comes from, although it's very healthy to do that. You're not going to come at an easy answer until you get into some more advanced math to be able to actually prove this. But just for now, just believe that it's true, 4 pi r squared. And it is true. So if you had an example, you would have, here's a sphere, okay, here's the diameter going all the way around there, and the radius of the sphere is 7 meters. That's the radius going from the center of the sphere all the way to the edge, okay? So the area is equal to 4 pi r squared, which is equal to 4 pi, and r is 7, so it's 7 squared. So the area is equal to 4 pi, and 7 times 7 is 49. So when you take and put this in your calculator, 4 times pi times 49, you're going to get 615.44 meters squared. And it's square meters because I'm dealing with area and I'm dealing with meters. So for area, you're always going to have square, meter squared, centimeter squared, etc. Okay. Another example on this. If you had another sphere, just to kind of get the hang of how to use it more than anything else, if the radius were given to you by 11 inches, then it's going to be the same thing. No big surprises. 4 pi r squared. Okay. And so that's going to be 4 pi times 11 squared. Okay. And so then the area is going to be equal to 4 pi 11 times 11 is 121. Okay, it's 121. So when you crank this in your calculator, or you can do it by hand, 4 pi times 121 is going to be 1519.76, and you're dealing with inches. So it's going to be inches squared, because this is the surface area. Surface area always has to have a square inches or square feet or something, and then you just crank through it. Now, the final thing we're going to talk about is the volume of a sphere. We've talked about the surface area of a sphere here. Now we're going to talk about the volume of a sphere. And it's the same sort of story as before. In order to actually derive the volume of a sphere, you really have to use calculus, and we're certainly not going to do that here today. So I'm just going to go ahead and give it to you, and we'll just move on. So here's our sphere, just as before. The sphere has some radius, r. Okay, it has a radius r. So the volume of the sphere is 4/3 pi r cubed. Again, you'd have to use calculus to figure that out, but you can already see that it has a pi r cubed here, so you're kind of somehow taking into account the third dimension there, because you have like a power of 3, and this 4/3 is some sort of conversion factor that makes that somehow work out, and you're just not going to be able to wrap your brain around that and just understand that right away. It's something that it doesn't jump out at you and say, well, gee, that makes a lot of sense. You have to calculate that using calculus, and we're just not going to do that here. So the bottom line is, remember this: 4/3 pi r cubed. So here's a sphere. Here we're going to do an example. Okay. Let's say the radius is 5 meters. Then the volume is going to be 4/3 pi r cubed, which is 4/3 pi. R is equal to 5 cubed. Okay, so we have to go ahead and do our cubing. 4/3 pi. 5 cubed is simply 5 times 5 times 5, which is 125. Okay. And when you take this and put it in your calculator, 125 times 3.14 times 4/3, which is a fraction, 4/3, then you will get 523.3 meters cubed. And we're dealing with cubic meters because we're dealing with meters, and we're dealing with volume. So we've got to have cubic meters, and the number is just the number that comes out in the calculator, or by hand, whichever you have handy. Okay, we'll do one more example here. Same story as always. Okay, in this final example, you have a sphere. In this case, you have a diameter of 6 inches. So we want to calculate the volume, which is 4/3 pi r cubed. And let's go ahead and plug in for the radius. 4/3 pi, and we need to put the radius here, but we're not given the radius, we're given the diameter. So we need to calculate the radius, which is just simply the diameter divided by 2. Okay, because here's the diameter divided by 2 gives me the radius, because the radius goes from the center. Diameter is 6 divided by 2, so the radius is going to be 3. Radius is going to be 3. So I need to put 3 in here, and don't forget it's cubed, 4/3 pi r cubed. So the volume is 4/3 pi. Now 3 cubed is 3 times 3 times 3, and I think you can convince yourself if you start multiplying that, that's equal to 27. 3 times 3 is 9. 9 times 3 is 27. So that's how you get that. And so when you crank this to your calculator, 27 times 3.14 times 4/3, you'll get 113.04. And the units are inches. And this is volume, so you have cubic inches. So we've covered a tremendous amount. We've covered a tremendous amount in this section. We've talked about surface area of spheres, the volume of spheres, surface area of cylinders and volumes of cylinders, and we've talked about cones, and we've talked about lots of different shapes, but all of those shapes have involved circles of some sort, and that's why this is all lumped into one section together. The cylinders have circles on the bottom and the top. Spheres, obviously, some kind of cylindrical, circular kind of thing. And you have circles at the bottom of a cone as well. So in all of those formulas, you'll always see a pi squared, a radius squared, or a radius cubed in this case, or something like this. And it's all because of the fact that you have a circle in there somehow, some way, shape, or form. And I think if you just use these formulas and practice a few problems, it seems like there's a lot of different formulas going on here, but I think if you just work with them and realize how they play with one another, you'll be able to memorize them and use them much, much easier.
Learn anything at mathandscience.com.